Oh, there's Benjamin. We were worried about you. We thought you died.
Yeah, you can't miss a class.
No, I cannot.
So Ben, yeah, you're too consistent to miss a class. It makes everybody worry. It's stressful. So, where was I? What was I trying to do? So I'm doing this overhead projector, right?
Yeah.
So the overhead projector is Ladybug.
I think that's close.
Power's on. Lamps on.
You should teach.
Okay. Is anybody hip to this thing? To Ladybug? To this projector?
I
think it's Ladybug.
Do you just turn it on and then open the app for the program?
Well, yeah, I've already done that. Like, I'm not completely butt stupid, but yeah, that's done.
Is it showing an image on that?
No, it's not showing me anything. And
You have to turn on the projector first, or?
it's not, yeah, the projector's on.
Is it maybe
You
one?
know the button that says power, and then you push it and it lights up? Yeah, that's happening.
Is there?
You try turning it on and off?
You have to
No, but
select on that?
come on, take a look. Let's see.
Because the projector's not on.
It's not this projector.
No, I think it's
This.
Oh, it's that?
Has nothing to do with that.
Oh.
Oh.
Nothing.
You know, he got locked out of his council. He
And
can't
I
get
think,
in.
I'm pretty sure it's Ladybug.
Out of his what? Out of his pipeline. so
I'm
he can't
almost
get in.
sure it's Ladybug, but.
Sorry,
Yeah, no, I
using
think
the
it-
Ladybug, which probably hasn't been used.
2.0.
The Ladybug, that's how it's called, Ladybug.
Yeah, it's called, yes, it's called Ladybug. And I, that's usually all I had to do with this thing.
Did you try to unplug it?
Oh, I think it just going, is it going straight into the projector?
Well, let's try that. We'll see if it's projecting.
Because it looks like it's connected to an audio and a visual in addition to the USB. So I think maybe the USB goes to the computer, maybe the video goes to
We'll
the
find out.
projector.
We'll find out. We'll find out momentarily.
That source button switches it.
There it is.
Can you see it?
No.
No, you just see it.
You just
see screens
for it. That's what I think. Why there it is, but yeah, I don't think I'm gonna do a project like that. I don't know why I haven't been able to get this guy to turn on. I think I tried it a little bit ago. Lamps are on, yeah, and I've got Ladybug up. Right, and it's got the picture of a dock. Okay, English, all right. Enable video compression, yeah, clear. What else we got here? What's that? A car? No. Now you're plugging and unplugging things.
Can I just unplug it and plug it back in to see if that would work?
It should show up on my screen. It really needs to show up on my dang screen.
Why don't we just get someone's phone, put it on Zoom, and duct tape to the top of the Ladybug?
Don't worry.
It's not that traffic cone?
What now?
No, that's VLC. That's a media player.
Yeah, no, it's Ladybug. It's Ladybug 2.0.
Oh,
No, I just turned that. Oh, dock cam.
there it is.
Damn, dock cam. So you know what? It's probably not even Ladybug. It's just dock cam. Right? Yeah, cool. It's not even Ladybug.
I don't know if the Zoom people can see that though. Or maybe if you.
Oh, that's right. They will. I'll have to
Camera.
do that. I'll get the camera up there. Don't worry.
We
Don't worry,
can
I'll
just
get
move the
that
camera
together.
right here, and I'll be able to see it.
Yeah. I got it. Just relax, everybody.
Did you take
Let me take it from here. So I remember where the hell I am.
And then
You're
also
right.
see the camera that's put down, look straight down.
Yeah.
I guess display, okay. Okay, cool.
Right.
So, oh, yeah, no, that's right. I gotta get the display.
Yeah, I think the stress level is pretty high right now.
Online.
Tech issues.
Stamp it up.
We really need Zach here because he's the IT pro.
Right.
Yeah.
Who?
Zach.
Are you recording, Ron?
Yeah, I'm recording things. Just let this thing stop doing its cycle. It's gotta stop cycling when I can get this up, and I'll pull up the, you guys can see. You guys at home can see, this is a really pretty cool thing here. This code of state practices, I just came across this. I was looking for some different topics. And let's see if we can't project that here by going, turn the damn dock cam off. Now I can't get the fudge sickling dock cam to turn off. So that's what I got off flashing. But they stopped it.
Right now?
Okay. No. So when you press dock cam, did it turn something else off? Okay, there it goes. There it goes. There it goes. No, it turned my PC off to dock cam. So yes, I know that. I could see that too.
All right. I'm trying to
Now back away. Okay, who came in? John? John Tapia came in. How about Joel Santos? Did you show up? Joel? No? Zach?
I'm here.
Eric?
I'm here, sir.
Wait a second.
Hello?
Who said that?
It's Joel.
Joel, you're there.
Santos. Yeah.
Okay. Joel, I got you, man. And what about Eric? No? Adair? Adair? Austin, did you show up?
I did.
Miguel and Matthew? No? Okay. Okay, now y'all can see that, right? Good. All right, I'll start out. This is a code of safe practices in carpentry. So by the way, just for a little background, how many of you are familiar with state compensation insurance fund? All right, so nobody. So here's what's happening with state compensation insurance fund. They are a gigantic insurance company, really big. And they handle workers' compensation insurance, believe it or not. They are the insurance company that you will buy insurance from as a contractor if no one else will insure you. Now, that's not the only reason you'd go to them. You'd go to them for a variety of reasons if their quotes are good, but they have to take you. No other insurance company has to take you or your company. They don't have to. State compensation insurance fund has to. They're mandated by the state of California to take you. So they're the main workers' compensation insurance people. They are hooked into the rating board for X mods, and they're the ones that we were with for a long time in our IIHP or IIPP. So you have to have an IIPP as a contractor, and that's an injury, illness, and prevention plan. You have to have it. So you have to have insurance, and your insurance gets audited. You have to have every subcontractor that you contract with as a licensed contractor. You have to have copies on file of their certificates of workers' compensation insurance. And if you don't have those on file, or if they're not in force, then when you're audited twice a year, you pay the amount of labor, the compensation, the workers' compensation rate for whatever that subtrade is on their labor. You pay it. If you're a general contractor and you're let's say I'm general contractor, and I'm subbing for the drywall contractor that doesn't have an adequate insurance, or his insurance lapsed. And I get audited and they go, oh, you don't have a cert form, it lapsed. And so they'll take the time where they weren't covered in any of the contracts you had with them, any monies you paid them, they want you to take those monies and then get them to break out what the labor part was, and then you apply their rate. Whatever they're paying, 25, 28, 30, $15, 100, whatever it is. So it sucks. It sucks not to have your ducks in a row. Consequently, they are a really good resource for safety topics. Their site is just filled with videos and all kinds of stuff about safety, as you'd probably imagine, because they have a vested interest in you being safe. With us working safe, then they have fewer claims. They pay out less money. They still make the same money. They just pay out less when you're safe, right?
Mhm.
Although that's not necessarily true, because X mod factors into that. So the safer you are, or the safer your company is, the less claims, or the absence of claims affects your mod rate. Your experience is called X mods because it means experience modification. And everyone starts out at 1. So if you're paying on the 100 for carpenters, $25 on the 100, that's how much you pay, 1. And if you have claims, your X mod rate can go like up 1 point, can go to 2. Mine went to 2.25. So instead of paying 25, I paid 62.50 on the 100. Your X mod, if you have no claims, goes down. I've had an X mod as low as 0.2. So whatever the rate was I was paying at the time for whatever the worker I was paying, I got to do that rate times 0.2. So a fifth of what the going rate was. So it's a pretty good deal to not have claims and to work safe. So a code of safe practices for carpentry. This is an example of a code of safe practices for carpentry. This is a sample to help a contractor create a code of safe practices that fits his or her operations. I'll read the first 2 or 3. Carpentry, 1. All employees are required to take appropriate new employee orientation as outlined in the company injury and illness prevention program. Illness prevention program. So the IIPP is a part of the company's docs. They have to have. And part of it is you're supposed to have a new employee orientation, basically to learn about what they need to do and how to stay safe. 2, employees must attend tailgate safety meetings that are held at least every 10 working days. 3, appropriate PPE must be worn by all employees on the job site at all times. The type of PPE includes, but is not limited to, hard hat, safety glasses, proper work clothes, safety boots, and high visibility vests. Let's go around this way and read. John, start with you.
4, housekeeping is an important part of every job. Employees are responsible for keeping their work area clean and free of known hazards.
Keep going. Read.
Number 5, employees who observe any unsafe work practices or conditions must report it to their supervisor right away. Number 6, all hand and power tools will be properly maintained, inspected prior to use, and used according to the manufacturer's instructions.
And let's pass it.
7, only use tools that are the right size and right type for the job. 8, tools will not be altered or modified by tying or blocking a guard. 9, all extension cords and electrical cords on tools must be inspected prior to use. Damaged cords or equipment must be immediately removed from service and can only be repaired according to the manufacturer's recommendations.
Ben.
Never point a nail gun at someone. Position, well, that was number 10. Never point a nail gun at someone. Position yourself at your free hand out of the line of fire and watch out for co-workers behind the nailing surface. Keep your fingers away from the trigger when not driving nails. 11. When using circular saws, always stand to the side when cutting to avoid potential kickbacks. Saw blades must come to a complete stop before removing the blade from the cut. Number 12, do not force the saw when cutting or carrying with your finger on the trigger switch.
Lou.
13, wear the right clothes. Baggy or loose fitting clothes increase the chance that a part of them might get caught in a cutting head or saw blade. 14, all compressors, tanks, hoses, and other pneumatic equipment shall be properly maintained. 15, a job site fall protection assessments shall be made by a competent person who oversees all fall protection equipment, inspections, training, and usage. 16, ladders must be inspected prior to use. If the ladder is damaged, it must be removed from service.
Dylan,
Ensure
extension,
extension ladders are placed on lifts,
level,
level flooring,
footing,
set up with a 4-to-1 angle, such
security.
secured and extended 3 feet above the work surface. Always face the ladder and
You're there. You got it. Maintain.
maintain three points of contact when climbing. Keep your body near the middle of the step or
Rung.
rug to keep the lead on the ladder contact.
The load on the ladder centered. Sorry for laughing. 19, you know all kinds of hard words in this, so we don't. Matthias,
Do not stand on the top cap or the step below the top cap or step ladder
I was
of a step ladder. Always use the proper lifting technique when handling tools, equipment, and materials. Keep the object close to your body and lift with your legs, not your back. Avoid turning or twisting your body while lifting or holding a heavy object.
and Austin.
General. Number one, that all persons shall follow these safe practices rules, render every possible aid to safe operations, and report all unsafe conditions or practices to supervisor or superintendent. Number two, supervisors shall insist on employees observing and obeying every applicable company, state, or federal regulation and order as is necessary to safe conduct of the work, and shall take such action as is necessary to obtain compliance. Number three, all employees shall be given frequent injury and illness prevention instructions. Instructions shall be given at least every 10 working days.
Okay, and 4, let's get some people from home here to start with 4. How about Matthew Aguinaga? You show up yet? Okay, Jesus, how about you?
4, anyone known to be under the influence of drugs or intoxicating substance that impairs employee's ability to safely perform the assigned duties will not be allowed on the job while in that condition.
Okay,
5,
so I think it's stop for just a second. I just want to point out, I think it's pretty cool that they say anyone known to be under the influence of drugs or intoxicating substances that impair responsibility.
But if you could do it.
Yeah, but if you're high and you can still do it, you'll be fine. No, I mean, if the drug is known to impair you. All right, go ahead. Sorry. 5.
5, horseplay, scuffling, and other acts that may prevent a job from getting done safely or affect someone's well-being will not be allowed. 6, work will be well planned and supervised to prevent injuries in the handling of materials and in working together with equipment. 7, if an employee's ability of alertness is impaired by fatigue, illness, or other cause that might unnecessarily expose the employee or others to injury, they will not be permitted to work.
Okay, Adier, did you show up? Adier? Gallardo, Adier? No? Zach, how about you?
8, employees are not permitted to enter manholes, underground vaults, chambers, tanks, silos, or other similar places that receive little ventilation unless it has been determined that it is safe to enter. 9, employees will be instructed to ensure that all guards and other protective devices are in proper places and adjusted, and report deficiencies to the supervisor or superintendent immediately. 10, crowding or pushing when boarding or leaving any vehicle or other mode of transportation is not allowed. 11, employees must not handle or tamper with any electrical equipment, machinery, or air or water lines in a manner not within the scope of their duties, unless they have received instructions from their superintendent.
Sorry, I cut you off. Brendan, take it from there.
12, all injuries shall be reported promptly to the supervisor or superintendent so that arrangements can be made for medical or first aid treatment. 13. When lifting heavy objects, the large muscles of the leg instead of the smaller muscles of the back shall be used. 14. Inappropriate footwear or shoes within or badly worn soles must be worn. 15. Materials, tools, or other objects shall not be thrown from buildings or structures until proper precautions are taken to protect others from the falling objects.
Okay, and then let's get Joel to read a little bit. And you know what? Stop right there. Joel, don't read. This goes on for quite some time, and we're not going to do all this. So just suffice to say, this 4-page document is in Canvas. It's labeled as, which is what it is. It's labeled as Code of Safe Practices Carpentry, and there it is. And in your modules, there it is, week 15, safety meet, Code of Safe Practices Carpentry. So if you get some questions about safe practices on your final, you'll know where to go for the answers if you need to look for the answers, okay? So we don't spend all that time. Let's get right into project that there, and then we'll get the Zoom camera on that. So we'll stop the share for now. We'll go ahead and end me, and yeah, how's that? Well, okay, we'll see how this works. We're going to show that. Let's see if I can get that back to a better spot. And then let's see what happens here. Ready? Displays on. Doc cam. Oh wow, that was fast. Faster than I expected it to be. Good. It's weird how turned around it is. Huh. Wow, how about that?
You're ready to turn off that noise.
What's that?
You're ready to turn off that noise.
No, if there was, I'd turn it off. No, I'm kidding. It's just the volume is up so high, so let's see if I can turn it down. How's that? Better? Better? Yeah, I had it way up to hear somebody. Way up, so let's see here. Okay, we'll just do it like. We'll do it like that. This is more trouble than it's worth, but for now. We're gonna do it for now. Okay, can you all see that?
Yeah.
Can you see that at home?
I can see there's a book.
Do I hear yes? There's some yeses?
Yeah, we
You
can
can't see it. So right angles, objectives. After starting this unit, you will be able to demonstrate an understanding of right triangle theory, establish a right angle using the 3-4-5 method, and determine the hypotenuse of a right triangle using the Pythagoras theorem. There are many types of triangles, but the one most commonly used in construction is the right triangle. What other types of triangles are there? Just out of curiosity. Anybody chime in?
Scalene and isosceles.
Obtuse angle, isosceles, equilateral, acute angle, triangles, but that, I don't think those are actual triangles. There's right triangles, there's isosceles. I said that, equilateral. Yeah, we said that together, and then you just chimed in on us, but that's okay. You probably didn't hear it, right? Anyway, so the triangles that we are pretty much concerned with, not pretty much, the triangle we are concerned with are right triangles, because they allow us to do things that are square. So while every triangle is a three-sided shape, a right triangle always, and I want to highlight always contains a 90-degree angle. A 90-degree angle is formed by two perpendicular lines and is also known as a right angle. So by the way, what does perpendicular mean?
Two lines crossing at a 90.
90 degree. When something is perpendicular to something else, technically it's 90 degrees. Now, you might say something's perpendicular just because it's offset or approximately 90 degrees, but the true nature of perpendicular is a 90 degrees to a plane. Perpendicular. So let's trace the etymology of that, huh? Okay, so many tasks, right angle, single, okay, so many tasks. All right. A 90-degree angle is formed by two particular lines is also known as a right angle. Many tasks in the construction field require constructing right angles, such as taking out a building or building a wall in a square. The right triangle is also critical in a variety of construction tasks, including determining the length of rafters and stair stringers. Knowing the mathematical principles of right triangles is essential for constructing sound and stable structures. Math tip: only a triangle containing a right angle is a right triangle. Right triangle theory: the 90-degree angle is often illustrated with a square box in the corner. With a square box in the corner. The two sides of the triangle that extend from the square corner are identified as by the lowercase letters A and B. Across from the square corner is the longest side of the triangle called the hypotenuse, identified by the letter C. Okay, I see. So there we go, right there, right? So there's a 90-degree angle. This is a right triangle. There's your A, there's your B, and there's the hypotenuse. And then we'll get into the Pythagorean theorem, I bet, any second now. A triangle is only a right triangle if the length of the hypotenuse is in specific proportions with the lengths of the other two sides. Two methods are used to determine these lengths: 3, 4, 5 method and the Pythagorean theorem. Example 21, to determine if a wall is square prior to applying exterior sheathing, two sides of the wall are used to make a right triangle. The lengths of the sides determine what length the hypotenuse needs to be to form a right triangle. So a wall measuring 8 foot high and 20 foot long has a diagonal measurement that currently measures 20 foot 10 inches. The hypotenuse should measure 21 foot 6.5 inches for the wall to produce a 90-degree corner or square wall. To ensure a square wall, the hypotenuse should be lengthened to measure 21 foot 6.5 by adjusting the walls. The wall leans to the right. You can see that, kind of obvious, right? That wall leans that way. It must be shifted slightly to the left to increase the diagonal measurement until the proper hypotenuse is achieved. Once the wall is adjusted and the diagonal length equals the hypotenuse, the wall is then considered square. This method of squaring the wall works on multiple construction tasks when a square corner is essential. And essentially, the way they got that is the square of one side of A plus the square of the other side. So the square of A, 20 feet, is 400, and the square of 8 is 64. So 464 added together, the square root of that number, of that quotient, and that's not a quotient, that's that sum, two things added together, the square root of that is the hypotenuse. Now, I'm not going to show you how to do square root. It's just too involved, and there's two ways to do it, and it's not something that I'm going to encourage you to do. And unless you've got a calculator that will calculate square root, then it's a piece of cake. Then, by all means, plug in the square of A and the square of B, get the sum of the two things, and then ask it for square root, and that'll be your hypotenuse. Now, an easier way to get a right triangle is how am I on this now? Oh wait, I'm not on this now. Oh, I'm on. So what are you guys seeing on Zoom? Do you guys, on Zoom, do you see me or do you see the screen?
We see
have a
you
bird.
and
The sound of the ladybug is
Oh,
activated.
yeah.
I love the sound of the Zoom. That's my opinion.
Can anybody hear me?
yeah, we can. Can you hear us?
Yeah.
Find out what's going on here. Hey, can you guys hear me at home?
Can you
Yeah,
hear
we
us?
can hear you.
Yes.
Oh, I did stop the shit. So you think the dot cam keeps them from hearing you?
Yes, the ladybug. Because
I
that
understand
sound
what you
started
would
when I had to get
did
it.
not want me watching it. So I was like,
Yeah, but I think ladybug is up. Can you guys hear me at all? You can?
Yes.
Okay, Jacob can hear me.
Yes.
whatever it makes that.
Jacob, do you unmute yourself and say something?
Yes.
Hello?
I can't hear you.
I see.
Yeah, Dad was the one that cared about this.
Yeah. Jacob, you can hear me?
I was just,
Yep.
I significantly remember
Jacob,
being
can
very
you guys-
disappointed when Tessa started watching it. And
what's
even
your-
more disappointed when I started watching it a year later.
We're golden. Okay, good. Good deal. Let's go back to the dot cam. Wait, dot cam is up, and why aren't they seeing it? I guess,
Probably seeing it through the camera.
yeah, okay,
Ask them.
okay. They can't answer me either. That's good, that's good. That's pretty good. That's pretty good. So Zach says yes. So, are you guys on Zoom seeing the screen? Okay, can you hear you? Can you turn on the light adjacent to the screen? It's quite white.
You already have one off, so it's gonna be like this.
I'm good with that. Is that better?
Well, you gotta put the light on the ladybug to shine better onto that.
Yeah. The light.
Cause you can't really see it.
What do you mean you can't see it? Of course you can see it.
We can see it, but
But the camera
the
can't.
light's not right on it. Half of it's dark and half of it's really light.
Well, too bad.
Well, I can see it.
It's too damn bad, Dylan. So Jason screen painting, never mind, not much better. That's not much better.
Okay, the light's coming back.
So,
I'm gonna fall asleep with this off.
okay, so I'll check the chat. You guys can hear me. I'll check the chat occasionally to see if there's any new info. But in the meantime, why is this even on? All right. So, did you get that? Everybody get that? Everybody get that at home?
Can you turn the sound down?
Oh.
Yeah.
Sorry. Can everybody hear me okay? Zach, hit me in the chat if you can hear. Okay, good. And you can see the dot cam too, right? Can you see the dot cam? Can you see what's projected? Yeah, can you see too? Can you guys see the dot camera? You see the book? Sort of, okay, well, sort of is better than nothing.
Well, can you put the camera in the middle so they're looking directly at it?
No, it's not the camera, it's they're seeing the dot cam, I don't think, maybe you think, just think they're seeing this. Oh, okay, maybe you're right. Is that in your way then? Is that, Zach, is that better? Okay, much better.
There you
Right on.
go.
Okay, so you see what I'm talking about, right? Because in we'll get to that. We'll get to 3, 4, 5. So once the wall is adjusted, diagonal length equals the hypotenuse, the wall is then considered square. The method of squaring the wall works in multiple construction tasks when a square corner is essential. The 3, 4, 5 method. A simple method used to establish a right triangle. A simple method used to establish a right triangle, a right angle in a triangle, is the 3, 4, 5 method. The method states that if a triangle is laid out using 3, 4, and 5 units, this is important, you guys, 3, 4, and 5 units as the length of the sides, the triangle is a right triangle. A hypotenuse will measure 5 units. So 3, 4, 5, right? 3 times 3 is 9. 4 times 4 is 16, right? So that's squaring. So to square 3, you do 3 times 3, that's 9. To square 4, you do 4 times 4, that's 16. 9 plus 16 is 25, which is the square root of C, the hypotenuse. That's why it works. And it works in units. It works in units of 3, 4, 5. So what works as perfectly as 3, 4, 5 is 9, 12, 15. What works perfectly is 3, 4, 5 is 15, 20, 25. So anything with that ratio of 3, 4, 5. So you can do So just call out any number. So you can, if you've got a big, long square you're doing, and you don't want to just do 3 foot over and 4 foot over and connect your 5 to get it to square to make that thing come out on 5. You want to get a little bit longer to get a little bit more accuracy. So you can take that as long as you want to go. Let's say you're limited by this thing's 20 feet long. Okay, fine. So let's go in that direction. Let's use the unit of 6. 3 times 6 is 18. Make a mark at 18. 6 times 4 is 24. Make a mark at 24. And then measure, because that should be 5. This should be 30, which is 5 times 6 from point to point on A and B. That hypotenuse should be 30, and you need to move one of the legs of A or B until it gets to exactly 30, and then you have a right angle. So I want to illustrate this on the board. So I'm going to stop the sharing and turn off the dock. Turn off the dock cam.
Recording in progress.
Trying to see on my phone what it showed up. Oh, it just joined right now.
Okay, so you're laying out something, right? You got batter boards. You got batter boards.
Can he make it?
I didn't want to get it close, just in that direction. I didn't care. I didn't care. Okay, you got batter boards. You got batter boards running here. You got a string running this way. And you got batter boards here, and batter boards here. And you got a string running this way across your batter boards. And you want to make this building corner, you're laying it out with string and then you're going to stake it. You want to make it square, right? And you don't want to hold a framing square up to it, because your framing square, because let's just say this thing is like 30 feet and it's say 90 feet this way. It's a big old building we're doing, a big old slab, right? You want to lay it out square. You don't want to do just a little 3, 4, 5, because really that might not be all that accurate, because by the time you pull that string, from just a little bit of a change out here is going to make a big change in here, right? So you could be even conceivably close to square and not be square. So you want to go out more. So again, we're going to use a 3, 4, 5 triangle to make a right angle. And so it's simple. From this point, you have an established point. You're going to measure over, you're going to have a string line pulled tight and made off around your batter boards, which run beyond where you want to go. And you don't need to measure yet, but you know that 30 feet over, you've got to stake, about where 30 feet is. So you're going to come, let's say we're going to use 9. So 3 times 9 is 27. You're going to measure 27 feet over, and you're going to take a Sharpie or an alligator clip, and you're going to put it on your string right there, right? That's 9 times 3. 9 times 4 is 36. You're going to pull a tape from here. You're going to measure 36 over, and you're going to put an alligator clip or a Sharpie on your string. You got to watch out for string, because you want to stretch it and keep it stretched tight, and then make your mark. But don't rely on that mark if you release your string and re-stretch it, because it's going to stretch differently, and your mark's going to be in a different place. Just do new marks after if you have to release the tension. Okay, so you've made a mark at 36 feet and a mark at what did I say? I said 27. 27 and 36, because we're using 9. Now, what's the other number?
45? No, what is it?
It's exactly 45. So you're going to put a tape, have somebody hold the tape right there, and you're going to pull that tape. And let's say that thing says 45 feet 4 inches. Is it square?
No.
What if it says 45 feet 1 inch? Is it square? No, it's not square. It's only square when it says 45. So you're going to take it off the batter board. And you're going to move it. You're going to have somebody move it. It's going to be anchored here. You're going to have them move it this way. You're going to move it this way, and you're going to move it until it comes right dead on 45. And they're going to go nail it. And they're going to make that string fast. And then you're going to double check just in case your string tension screwed up. You're going to measure 27 again, make sure your 36 is right, pull that tape, and if it says 45, guess what you got? Square. This is dead square. It can't be anything but square if that number comes in. Right? Now remember, you can also move this leg too. You can move either of these two legs. Typically, you'd have your long one, you'd kind of know where that's going and then move your shorter leg to get in a square. Okay, did everybody see that? Let's go back to the dock cam. Display on. The dock cam's on. It should be dock cam. They got, I think we were using Ladybug before Warren got this thing really together. Warren really did well on this. Tweaked it for us. Boy, this is it. This is our last class together.
Bittersweet.
Mm-hmm.
No more measuring and calculating.
I have really enjoyed this class.
That's good a lot. We should do it again next semester.
I want to. I hope to.
Wait, so it's Saturday? What time again?
Okay, so I'll just stop for a second as an aside because Matthias asked me a question. Next semester, spring 2022. Basically, I think CT is offering 3 classes. Patrick's doing 122, which is green building. It's a 6-unit class. Jim and I are offering 111, which is what the hell is it? It's the continuation of 110. So it's beginning construction, but we get into house systems, we get into drywall and insulation and plumbing and electrical and and roofing and just a bunch of stuff outside of what we got into this go around. So 114 and 114, which is beginning finished carpentry. So I'm teaching that, I think, on Thursday nights. I need that thing to fill up. So if you guys are interested in it, please take it. And Jim and I are splitting 111. And 111 is the same as 110. Essentially, it has a lecture component and then a lab component. And the lab component would like to do something hands-on if we possibly can. It's tough to do at night. It's tough to do at night when it's dark. It's tough to do at night when it's cold. It's just tough to get something going. Like we can't really go erect this shade structure.
Weren't you guys doing that class in the morning and Patrick's taking the afternoon class?
Yeah.
Which class?
The 111 class.
Building green.
No, that's building green, 122. 111 is basic construction.
But it's in the morning, right?
No, it's not. It's advertised in the scheduled classes as lecture on Tuesday and lab on Tuesday, lecture on Wednesday, just like this was. And so we changed it to lecture on Wednesday, lab on Saturday morning. So lab is Saturday morning between 8 and 1. Now that brings me to another point. If you're interested in this class, you're considering this class, it's changed and the scheduling should change it. So by tomorrow, even today, you should be able to go to scheduled classes and see that it has changed. The lab has changed to a Saturday. Both Jim and I will be on there as co-instructors, so we're going to split it 50-50, lecture and lab. So essentially the way I kind of see it working is that I'll do a lab and lecture, or a lecture and lab, and then the next week he'll do a lecture and lab, and we'll piggyback, or we'll do some combination of that. But this interesting thing is that this is a 4.7 unit class, that 110, CT110, 4.7 units. CT111 is also 4.7 units. Well, CT110 calls for a total of 7.16 hours a week. in the classroom. That's what it calls for, on the schedule, even though I try not to make you stay that long. And I think Jim tries too. Not the same class, but the same number of units, CT 111 requires 9.75 hours a week in class. They want you guys here, before we changed it, they wanted you here from 6 to 10:05 one night, and from 6 to 9:05 another night. Yeah, 6 to 9:05. Anyway, if you're interested in those classes, you can disregard those numbers. They're not going to happen. Just so you know, okay? I won't say anymore. I don't think I need to say. I don't think I need to say anymore.
Was that recording?
Yeah, I was recording. It's okay. Let them comb through. Oh, we have you on tape, Mr. Rutt. I still didn't say it. You guys can barely see that, huh?
Yeah.
Barely see that. What is that? You can see it fine there. You can barely see it at
Here's
all.
what it looks like
Is it
from-
even backwards? Wait,
Here, just check this. Hey, Rod,
yes.
this is what they see.
Can barely see this.
Somebody spoke.
Gotta move the camera in a little closer.
Okay, let's see if we can't get it closer.
We'll move the video camera in closer, not the ladybug.
Because that's just
Okay.
gonna be more fritzy. Like,
Yeah, let's stop calling it ladybug and start calling it what it really is, which is the dot cam. I know you
Dot
probably
cam.
got it from me, but. All right.
Isn't that,
It's red, it's circular, it's pretty much a ladybug.
isn't that what it was, you guys were calling it, was a ladybug?
You're right. You remembered right. It's just that's what we thought the app that ran the dock. And it was, but now it's just straight dock cam. And now we're calling it dock cam. So is that better, John? Is that better?
It's hard to make
Oh, it
out.
was correct last week, but we changed it.
Okay, well, just listen up. See, do the best you can do there, folks. I wonder, it doesn't make a difference when the lights off. Hit the lights for one time, please. So nasty.
And then move the lights on the dock camera.
That's a little better, isn't it? And then let's see if I can zoom a little on this. It is? Is that getting any better?
It's too bright, right?
Yeah, so you may need to move one of those lights back just a bit. Yeah, that's better.
Is that better? All right, cool. So, the 3-4-5 method. There's an illustration of the 3-4-5 method. Any multiples of 3, 4, 5 will work to establish a right angle, such as 6, 8, 10, 12, 16, 20. For accuracy, it's best to use a multiple that fits the size of the project. Different size layouts can be squared using variations in the 3, 4, 5 method. So there's a 12, 16, 20 method. See a little bigger thing there. All right. So a 12-foot by 16-foot patio is to be staked out. The first corner stake is established at A. Then a stake is placed 12 feet away at B. To make sure the patio is square, the placement of the third stake, C, is located by viewing the two sides as part of a triangle and determining the hypotenuse using the 3-4-5 method. A right triangle with sides of 12 and 16 has a hypotenuse of 20. That measures 20. The third stake is placed by measuring simultaneously with two tapes, 16 feet and 20. The third stake is placed where the two tapes intersect at C. I know that was a lot of verbiage, and hopefully everybody got that. And then before we do the Pythagorean theorem, we are going to take a break. We're going to have this break, we're going to have another break, and then we're going to go and we're going to leave. So I got almost 5 till. Take a short break, come back at 5 after, and we'll keep going, okay? Come back at 5 after. Please. It's 133. Oh my gosh, really?
Yeah.
Okay. Okay, so we're recording again. We're back live. I guess we've got a few people haven't come back yet. That's okay. We're gonna keep going, and we're gonna turn that display back on. Display's back on, so we can look at the book a little more. Soon that display will come up. Comes. Just like we do. Okay, so the Pythagorean theorem. Come on, we got Pythagorean theorem. Also known as, AKA, Pythagoras's theorem. It's named after the ancient Greek mathematician Pythagoras, believe it or not, who lived over 2,700 years ago. The theory states that the square of the hypotenuse is equal to the sum of the squares of the two shorter sides. So a squared plus b squared equals c squared. Square is defined as a number multiplied by itself, such as 4 squared equals 16 or 4 times 4 equals 16. The Pythagorean theorem can be demonstrated using 3, 4, 5 variables. A squared plus b squared equals c squared, or 3 squared plus 4 squared equals 5 squared, or 9 plus 16 equals 25. 25 equals 25. The formula can be rearranged to determine the length of any side of the triangle that is not known. When the hypotenuse C is not known, use C squared equals the sum of A squared and B squared. Yeah, kick that kickstand down. There you go. Or kick it down with it almost closed. Yeah, there you go. There you go. When A side is not known, when A side is not known, you can use C squared minus B squared. A squared. And when the B side is not known, you can use B squared equals C squared minus A squared. So you got to know two of them, and then you can figure the other one. Once the square of the length is determined, its square root must be calculated to find the value. A square root is a number that produces a specific quantity when multiplied by itself. To determine a number square root, a calculator is needed to perform the operation by use of the square root key. I don't think I have it on the phone.
Square root, you just put it sideways.
Oh, that's right. That's right. Did you show me that?
No.
Somebody showed me that. Now it all comes back.
I got a square root left. We have to unlock the code.
No, it's not. It's not.
I got from math for the math class section.
It's not like that. So hang with me. No, it's not locked. It's not locked.
Maybe you have the turning lock.
Yeah, I thought because you know, if I go to my gallery, yeah, I must have it on there. You know where you find it at?
Well, in mine, I do this. So let's say that's the screen. And I go up here and then I slide down.
Yeah.
And then it's this little lock right there.
Yeah.
I don't know if that's.
Yeah, mine's different. But this mine's a Droid. Connection center, display, themes, lock screen, screen lock, always on display. Widgets, notifications. Something locks there. Metrics, location, advanced features. Okay, so we're not gonna use my phone for that. Okay, so you guys are coming in a little bit washed out. Let's go back to those lights out. You'll see a lot better. And I'm turning this heater off. Doors slightly closed. In here. Okay. So one side of a right triangle measures 6 feet. The other side measures 8 feet. In this case, the hypotenuse is not known. So the formula C, which is the hypotenuse, C squared equals A squared plus B squared is used. So C squared equals A squared plus B squared. C squared equals 6 squared plus 8 squared. So that means C squared, the hypotenuse, equals 36 plus 64 equals 100. So C squared equals 100, right? So we need to know the square root.
See that right? Yeah, we're looking at the last page.
Oh, shit, I'm sorry.
That's okay. We gotta get good at your hands, bro.
Pretty good, well manicured too. I gotta admit.
Looking pretty good today.
What is that, 18 carat ring?
Say again, please.
What is that, an 18 carat ring?
Yeah. Yeah, oh, see if you can see this. Can you see the inside of that ring?
No.
It has the date, otherwise I forget. Seriously. See, and honey, when's our?
You know, there's a calendar on your phone. There's a calendar on your phone that you can put the date in,
Yeah, I've heard that somewhere.
and then it sends you a reminder.
I've heard that somewhere too. Okay, so now determine the square root of the sum to find the value of C. So basically, if you get A squared and B squared and add them together, you're going to get a number. And to get the side, you need to get the square root of it. So 100 is an easy one, right? Everybody knows the square root of 100 is 10. So let's see what I get. I bet we get a little bit more complex in there. So here's another example. Side B. Side B of a right triangle measures 24 feet. And the hypotenuse measures 30 feet. In this case, side A is not known. So the formula to figure A is C squared minus B squared is used. So so 30, so it's 30 minus 20. So 30 squared minus 24 squared. So 30 squared is 900. 24 squared is 576. So 900 minus 576 is 324. And then you need the square root of 324. So just plug that into one of your phones, turn it sideways.
324 square root is 18.
No, you want to, yeah, square root of 324 is 18, right?
Mhm.
And then you can prove that easy enough, just 18 times 18 is 324. Now you can do square root longhand. It's not that tough. It's just it's a process. But if you've got that thing on your phone, use it. It's really worth it. And like I said, I'm not going to take the time to show you use square root longhand because I'm done with doing that. So here we go. There's another example. So side A of a right triangle measures 12 feet, and the hypotenuse is 20. In this case, side B is not known. So the formula is to find B, you take C squared, which would be the hypotenuse, and minus A squared. Okay, so it's 20 squared minus 12 squared, which is 400, minus 12 squared, which is 144. The answer is 256, and then you got to take the square root of 256, which if you plug that into your phone, everybody knows that's 16. And then 16 times 16 is 256. So that's a triangle with a hypotenuse of 20 feet and a leg of 12 feet has a B leg of 16. So you can work backwards if you know two of the legs of a triangle. You can work backwards. When using the Pythagorean theorem, to determine the hypotenuse of a right triangle, often the length of the hypotenuse will contain a decimal. So 23.74593 feet. Well, I'd get that pretty damn close to 0.75 feet, and 0.75 feet is how many inches? How many inches is that? 0.75 of a foot.
9 inches?
Yeah,
9 inches?
exactly. It's 3/4 of a foot. 4 into 12 goes 3 times 3 times 3 times 3 is 9 inches. Because it's 3/4. The whole number represents feet, and the numbers to the right of the decimal represent decimal equivalents in feet. In the construction trades, this type of an answer cannot be used in its present form since 0.74593 feet cannot be located on a standard tape measure. When this occurs, the decimal equivalents in feet need to be converted to feet and inches. This process was covered in 15. You all remember it? I hope. I'm going to go back at this point. And estimating stair carriage length. So during the construction of a home, a deck, or any structure that requires stairs, the carpenter must lay out, cut, and install the stair carriages that will support the treads and risers. To determine what length of stock would be suitable for the carriages, stair carriages, shown below, the Pythagorean theorem is used. So we have an A and B leg, 108 inches and 140 inches. And so here are the steps to find out how long that stringer is, or carriage. In this case, I call it carriage. I call it stair stringers. The first step is to convert the inches to decimal equivalents of a foot. So the total rise is 108 inches, which is 9 feet. And the total run is 140, which is 11 foot 8 inches, which is 11.666. You know, all know how we got that, right? We took 11 feet and then 8/12. And 8/12 is reduces to 2/3. And then to turn 2/3 into a decimal, you just divide the bottom number into the top number. And that starts with point, and then we get to decimal, it's 0.666 or 0.67. So we'll take 9 feet squared, which is 81. We'll take 11.666 squared times itself, which is 136 and change, 0.09556. Right? We'll add those together, and there's our hypotenuse. There's how long our C leg is. It's 217 inches, 217.09 inches, which is pretty close to 0.09 tenth. Let's see if this they reduced that. A hypotenuse of 14.734. Wait, where are we at? Okay, now determine the square root to find the value of C. Okay, so we have to take that C and get the square root of that. And so the square root of that is 14.734. So, and that's feet. So the hypotenuse of 14.734 feet does not need to be converted from decimal equivalents in feet to fractions because lumber is purchased in even lengths, 12, 14, 16, etc. Accounting for angles and weights, a 16-foot material will be required to cut and install a stair carriages. So you see that, right? Comes at 14.7. So you know a 14-footer isn't going to get it. You can't buy a 15-footer, so you got to go to a 16-footer. Everybody get that? Okay, so let's review. Let's review this baby. By the way, I might want to cover. My wife leaves. I have to get up at 3 a.m. And yeah, get my wife, bundle her in the car at 4 a.m. and get her dropped off at Santa Barbara Airport. And I probably won't be able to go back to bed either. So let's just do a little review here. Determine the length of the missing sides of a right triangle in the table below. Convert all answers to fractional feet and inches. Fractional feet and inches, okay. So we got side A is 12 feet, side B is 18 feet. So let's come up with that number. And actually, you know what? I will do these on the board. I think I'll do the reviews on the board. That'll be a lot easier. Don't you think?
Yeah.
Lights, please. Lights, camera, action. Dock cam off, display off as well. But really, everything's gonna be in the book. So if you, and the book's not that tough, I don't think. I think the book's pretty well written, pretty easy to understand. The questions will be in the book. What I might do on the test is I might just change some of the numbers, so the answers might be different, but it'll be in the same sort of format. And then I might come up with some stuff. I might throw in some stuff. Also, I might throw in some stuff, just, I might make up some problems for you, but it won't be, it'll be all based on stuff that we're talking about, that we've been talking about. But here's something that you gotta remember, okay? That we're not gonna come here next week. So, and we're not gonna come, and you and my Zoom people, you're not gonna come on Zoom either. So you don't need to check in on Zoom. You don't need to come here. Okay? You just need to take the test. I'll send out an email blast and I'll tell you when the test will be available. And I'll pretty much tell you that the test will be available probably from 6 to midnight on this day next week. Unless you need something special set up, like Lou won't be around. He needs something special set up, so I'll have something for him either before or after that time. And anybody else that can't make it, and I think Zach, you said also, right, that you had something?
Yeah.
You couldn't do it on Thursday night. But
Can you
you
hear
won't
me?
have to come here and you won't have to come on Zoom. You'll just have to go to Pipeline, to Canvas, to the module, to the week 16, the test, click on it and click on the final exam and take it.
Will you be available or not really? No, you won't be around on that during that time, no?
I wasn't planning on it. I've been thinking about that. That's a really good question. I will be around and I will be available. I was gonna just do Zoom at my house and have everybody, check in and then, I still could do that. Would you guys rather do that? Would you rather check in on Zoom and ask me questions and let me give you some direction? Like the direction is gonna be take the test, but
I'm not gonna be around to take advantage of it, but Patrick did that for his final and midterm, and it was helpful.
Okay.
Needed
Okay, well
clarification.
then let's do that. I will reiterate, I don't think I'll come here. It won't really matter where I am to you guys, but don't come here. Because I may not come here. I may just do Zoom from home. I have a whiteboard at home too. But I'll have a Zoom meeting at 6 o'clock and everybody come on Zoom. And then, I'll get you started. We can get going on the test. We can talk about it. Maybe I'll give you a few pointers or whatever. And then I will be around available if you need to call me or text me or whatever. I will be available. Should be. My wife's leaving for 11 days, so I'm going to be just stuck doing nothing, twiddling my thumbs.
Where to?
Crossword puzzle. She's going to Wichita, Kansas.
Why?
That's where her parents live. And her sister. Yeah, Wichita. Wichita's pretty cool, really. It's the dead center of the country. Dead center, period. North, south, east, west. Dead center of the country. So when you get to Wichita, you're halfway across. It's cold there now. And the wind blows there, and you can buy a bitchin' house for a couple $100 grand. I mean, really, like 2-story brick house with a swimming pool, 3,000 square feet.
You moved to Wichita?
No, I don't want to live in Wichita.
Well,
No, we were just there. Yeah, my in-laws live on a golf course. I mean, they have a beautiful house. I think they paid like $360 for it 13 or 14 years ago. It's huge, and it has a completely built out downstairs with 2 bathrooms downstairs and a pool table and a ping pong table and 2 bedrooms and a bar, and it's just unbelievable. And then when we stayed, we did an Airbnb for my father-in-law's birthday, his 90th birthday, August 27th. We got them an Airbnb and we walked in that neighborhood, just a beautiful old, this College Park neighborhood. Looked at a house, looked it up on Zillow, it was like 265 and it was swimming pool, brick, 2-story, just a beautiful house. But it's in Wichita, Kansas. I don't know in Wichita. I mean, my wife will live in Wichita eventually. When her parents get really bad, you know, when they get sick, something happens to her parents, which God forbid, but nobody gets out alive. It'll come to that. You know, she'll go there for protracted stays, and I'll probably have to wind up getting a place there. But I'm not ever going to really live there or move there. You know, I've traveled fairly extensively, and not just the United States, but pretty extensively in the United States. Traveled in Europe, in South America, and in Canada. I don't want to live anywhere else but Santa Barbara. I've seen a lot of places too, and there's a lot of beautiful places out there, but nothing even gets close, as far as I'm concerned, to Santa Barbara. So let's just do a few problems and review. Figure out some of these problems, all right? We'll do problem number 1, which is side A and B. Side A is 12, side B is 18. So 12, 18, what's the hypotenuse, okay? So 12 times 12 is 144, 18 times 18, I need somebody on a calculator, please. 324. 324, add those together, 864, right? 468. Right?
Yes.
What's the square root of that?
21.63.
And that's the answer. And to prove it, multiply 21.63 times 21.63.
Hey, on the test, I have
Yes.
a question.
Yes.
Is it gonna be multiple choice or we're gonna have to define the exact number?
I gotta,
You need to be fill in the blank. Don't give them ideas.
So, Matthias, I guess maybe you came in late and didn't hear what I had to say about that. But yeah, so it was just too much trouble, I thought, for me to go back over everybody's test and go to every dang incorrect answer and see if it really was incorrect. It took me forever. So to avoid that, there should be no fill in the blanks. It'll be no fill in the blanks, it'll be a multiple choice. So I'll write the right answer and then I'll write 3 wrong answers. And then you'll need to pick the right one. Now, if you answer, I don't think in Canvas you can answer 2. So on a paper test, if you answer 2, it's wrong. And so there will be one right answer.
So
Okay,
Rob,
yes.
will the results be available after midnight once the test? Okay.
Yeah.
So we won't have
Yeah,
to wait.
no, you shouldn't have to wait. It should go, I should be able to set it up. So as soon as the test ends, you'll be able to get the results. Okay, the next one on here is we got a B of 15 and a hypotenuse of 21. So, by the way, this is A, this is B, this is C. So the hypotenuse is 21, and we got an A leg, or I'm sorry, a B leg of 15. Right? So we're going to take 15 times 15 equals what? 225. How about that for some fast math in the old head? Not bad, huh?
Good job.
Pardon me?
Good job.
And 21, what?
441.
What is it, 441? Okay, and so we need to take 225 and 441, which is what? Right? 116?
216.
216, sorry, 216, right? And now we need the square root of that. What is it?
14.7. I rounded, is that okay? It's 69, but I said 7.
Yeah, that's good. I like that. So it's 14.7 feet, and we can turn that into inches. We know how to do that, right? This is 15 feet, that's 21 feet, that's 14.7 feet. Does this give us the answers on it? It doesn't.
Maybe
Yeah, I'll have the answers tomorrow. Hopefully I'm right. I'm sure I'm right. That's the formula, right?
Yeah.
That would be it. To get, I just gotta get my head in the game here. Come on, come back in the game.
It is right.
It is, okay. Okay, so then let's look at number 3. Number 3 has got a 10-foot side and an 18-foot hypotenuse. $10 and 18. So that equals 100. 18 times 18, what's that?
324.
324?
Well, that's what I got.
18 times 18?
Yes, 324.
And then 100 from that is 224. What's the square root of that?
Of 224?
Yeah.
14.96 or just 15.
There you go. I tried around that to 15. That's that answer. So it's pretty easy, right? You know 2 legs. If you don't have the hypotenuse, you just add the square and the square, get the hypotenuse, right? Square of A, square of B, get that number, get the square root. So you're gonna need a calculator that gives you square root. And I'm gonna need to get my phone to flip around to answer them myself.
So Rodney, I guess it probably doesn't really matter, but on the test, so in the book, it gives you it in feet and inches.
Yeah.
Is it on the test, is it gonna be in feet and inches or a decimal? Like,
It'll probably be feet and inches, yeah. Well, it won't matter. I'll give you answers it'll be whatever it is, all right? The answers I give you as multiple choice will either be as a decimal foot or they'll be feet and inches.
Okay.
And that's what you'll have to pick one. So you won't really have to. So I think it'll be a lot easier than the way I did it before with the fill in the blanks. It's really, I mean, really, how hard is multiple choice? You have a 1 in 4 chance of getting things right. If you have no idea, odds are, you can go through and just.
Sometimes it's harder though. Because you'll put like 2 questions or 2 answers that are really similar, or they're just off by, you can be
Listen,
tricky.
the right answer is the right answer.
Yeah.
So, and numbers are pretty simple. If you get the right answer, because, obviously I'm going to throw in some numbers that are going to be pretty close and similar. One of them is going to be right.
Yeah.
So you're going to have to do the math. You're going to have to do the math. So let's do one that's a little different here, okay? And then we'll find the hypotenuse of 19.6 by 27.3. So we're going to find the hypotenuse of a triangle. It's 19'6" by 27.3. So we know the 19'6" and the 27'3" side. Now, how do we find out the square of 19.6? We need to turn it into a decimal, correct?
Yep.
So 6 inches is a pretty easy decimal. It's 6 over 12. What is that as a decimal? 0.5. 6 over 12. Come on.
2. 6. It's 0.5, no?
0.5. I thought you said 0.25.
No.
Yeah, it's 0.5. It's a damn mask. It's 0.5. So it's 6 over 12, which is 6 12s. Reduce that to 1/2. Half is 0.5. That's one of the easy ones. But you can always figure it with just doing the math. So 19. So that's going to be 19.5 times 19.5, which is what?
380.25.
380. It's absurd. Let's try it. 380.25?
Yep.
380.25, which is okay, 380.25, and then what's 27? Okay, 27'3" as a decimal is what?
1/4.
Yeah, 0.25, right? So it's 27.25 times 27.25. What's that?
You want the square, that square?
Yeah, squared. Hell yes.
That is 742.56.
Okay, we're gonna add these together. 1 carry the 1 is 8, 2, 2, 1, 1. I think that's right. Now we need the square root of 1122.81.
33.5.
And we happen to know that 33.5 feet is 33 foot 6 inches. And so that's a question. If I gave you that question, this is all, by the way, this is always A, always B, always C, right? A, B, C. If I gave you the A leg at 19.6 inches and 27.3 inches, I would want you to give me it in inches, not in point, not as a decimal, okay? Not as a decimal part of a foot. But if I gave you this as 19.5 and 27.25 feet, then I want the answer in decimal, right? Okay. The shed deck measures 12 foot wide and 16 feet long. What's the diagonal measurement of the floor? A shed deck. Oh, okay. Okay, well, that's simple. That's pretty cool. A shed deck, 12 foot by 16. Okay, I like that. So you can figure out all kinds of fun stuff, right? Not just right triangles. So you got a deck, right? A shed's deck, and it measures 12 foot, 16 feet, and you need to know what the diagonal is. We know how to figure that out, right? Don't we? Well, hell yes, we do. Because we know that we got a leg at 12, we got a leg at 16. So 12 times 12 is 144. 16 times 16 is 254?
256.
256. 256. Those added together are what? That's 400, right? Isn't that 400?
Yeah.
And what's the square root of 400?
20.
Yeah, 20. So a really interesting thing is that we did it with the Pythagorean theorem. How else could we have done it?
3, 4, 5 roots.
Exactly. So if you get some numbers that are multiples of 3, 4, if you've got a number if you got A and B that are multiples of 3 and 4, then you're golden, right? Yeah. So you just take a look at, okay, well, 4 goes into that. 4 goes into that 3 times. 4 goes into that 4 times. So this has got to be 5 times, right? It's got to be 5. 5 times 5 is 25. But that's not right. 20. That's not right. No, it's because I'm using 3. It's not 3, it's 4.
No, but that's the result. You divided 12 by 4, it was 3. Then 16 by 4, it was 4. And then 20 by 4 is 5.
It's 5. Yeah. Yeah, that's right. That's right, right?
Yeah.
Yes. Okay, and that is right. It says 3, 4, 5. Okay, Jesus, man. Get slow in my old age, in my old evening. Do we have our last break yet? No, we've only had one break so far, right? Yeah. I can tell time. Okay, let's keep going here. What's the diagonal measurement of a wall measuring 9 foot tall and 20 foot 6 long? Well, a wall is 9 foot tall and 20 foot 6 long. So here's the wall. It's 9 foot tall, 26 foot long. If for some reason we want the diagonal 6, right? So again, it's back to the 81, 26 and 26 is
it 26 or 20 foot 6 inches?
no, it's 26. Yeah. No, I'm sorry, you're right. 20 foot 6. Yeah, you got it both. 20 foot 6. So we're gonna make that 20.5 feet, right? So what's 20.5 times itself?
420.25.
420, smoke some weed, 0.25. So 9 times 9 is 81, plus smoke some weed, 0.25 is 501.25. And what is the square root of that?
22.4.
There you have it, folks. See, simple formula, not too hard, right? So really, these are all pretty much, okay, well, let's do number 13. 13 shows that determine the height of a gable peak shown below. All right, right to the center, that's perfect. So we got 12.6 and 15.6. So we got a gable. They want the height of the peak, okay? So we got a gabled end like this. Right. All right, not very well drawn. Well, that's 15.6 and 12.6. So we know we're 15.6 to here. And we know we're right to the center, we're 12.6. So if this is the span, what is it to the center? What's it called? Okay, so the whole length, outside wall, the outside wall is called the span, and the length from the outside wall or outside wall to the dead center of the ridge is called the run. Run. Okay, so if I talk about run, you'll know what I'm talking about. Just like if I talk about span, you know what I'm talking about. Okay, so let's go ahead and do the math on this. We need to find this out, right? So we already have the hypotenuse, which is good. Let's go ahead and get that 15.5 times itself is what?
240.25.
240.25. And then the run, or the B leg, is 12.6, which is 12.5 times itself. What's that?
156.25.
156.25. So those cancel themselves out. So that's 44. So it's 84. Is that possible? Yeah, 84. And then we need the square root of it, right? Yeah. So 84, right? 156, that's definitely 84. And then what's the square root of 84?
Of 80.
9 and something, right? Isn't that?
9.16.
9.16.
Yep.
And then you need to change that 16 into a decimal. You know how to do that, right? We all know how to do that, don't we? I don't think I can stomach going over converting fractions and stuff with you guys again. So what we're going to do is we're going to do a few more problems, and then we're going to probably go maybe till 8. Maybe we'll do a few more problems and we'll BS a little bit. And then do you guys mind going home like at 8 o'clock? No? Good. Because really, you just need to review the book. Just review the book. I mean, this is all relatively simple stuff, but I want to spend some time with you going over the back. So let's pick one more problem. Let's pick a problem. Cabinet, right triangle, hypotenuse. It's all the same stuff.
Can we do 17?
17, sure, love to. Okay, based on the staircase shown below, what would the length of the stair carriage be? Now, remember, I haven't shown you how to lay out and do how to cut rafters. I haven't shown you how to cut stairs either. Okay, and I'm not going to, but I will next semester. So just stay with it. Now, and if one of us, if I plan to, or you may get it from all 3 of us, but I would love to show you my whole stair thing. I have a whole thing on stairs. Get you up to speed on total rise, total run, unit rise, unit run. And the rafters are all other things, but stairs are my thing. So let's take a look at 17. So we just want to know how long our stringer is, right? How long to cut the stringer. Based on the staircase shown below, what would the length of the stair carriage material be? So round up to the nearest even foot. So remember, we're just going to get the length of the stick we're going to buy. Round it up to the nearest even foot. So we need to find out basically what the hypotenuse of this triangle that's created by the run, the total run of the stairs and the total rise of the stairs. So we got 41.25 by 37.5. Is that the height? That's inches. And 41.25.
Yes.
Inches. And we need to know this dimension so we can get this, we can cut the string. So we're gonna do 37.5, 37.5 inches times itself is what?
1406.25.
1406.25. And then we're gonna do 14, because we're gonna change that 1/4 inch to what? What's a decimal
25.
equivalent? 0.25. So what's 41.25 times itself?
1701.
1701 even?
0.56.
0.56?
Yes.
Okay, add those together, please. 1406.25 plus 1701.56.
3107.
107.81.
81.
And then square root of that.
55 3/4.
Okay, so 55 3/4 inches. We need a 56-inch strainer, but I figure a 5-footer. Cut it out of a 5-footer. You can't buy a 5-footer. You have to get a 6-footer. You can't really buy a 6-footer either. You can buy a 12-footer and get 2 6s out of it. But you're gonna have, because typically you don't have one stringer anyway. Usually stringers are in pairs. Stair carriages are in pairs. So I would buy, I'd get a 10 for that baby, right? Give you 2 5s, a little bit of waste, not much, so you can cut off the bad ends. Okay, Lou, does that answer your question on 17?
Yeah, thanks.
Okay, so some really good material in this book, y'all, all y'all. By the way, that's a plural of y'all. It's all y'all. And that's going to be on your test. What is the plural of y'all? So you've got decimal equivalents of fractions. Great. So you don't have to do a lot of calculating. You know, you come up with like, yeah, 0.4375. That sounds like, yeah, okay, that's 7/16. Or what's the fractional equivalent of 0.9375? It's 15/16. And if you study these and use these tables, it'll start clicking for you. You know, like 0.125, 0.375, 0.625, and 0.875. What are those?
The 8s.
Yes, they're the 8s, the odd 8s, the 3/8, the 5/8, 7/8, right? And you'll use those a lot. So you'll convert those a lot. So when you see, and then the easy ones like 0.25, you know that's a 1/4, 0.75, you know that's 3/4. The 8s are a little bit more, but you'll use them enough. 0.125, 0.375, 0.65, 0.875. Those are the odd 8s. And then the 16ths are a little bit trickier. 0.0625, a little bit trickier. 0.0625, 0.1875, 0.2375, that goes from there. That's a great table. That's a great table. And then inches converted to decimals of feet, right? So 2 3/8 inches, man. You want to know what that is? In a decimal of a foot, it's right there. It's 0.19792. That's worth checking out. And why do the math when you can just go right to the table and convert it? Really good tables. And then conversion charts, inches and feet, yards, right? Mile, area, volume, conversions, 26 cubic feet, the big one you're going to want to know, which is cubic yard. Yeah.
For the final, is
Yes.
it gonna be cumulative or is it just kind of the second half of the class? That is gone over?
Cumulative.
Okay.
I won't do much.
Is it, so it's gonna be kind of more weighted towards the second half of the?
Yes, way more weighted towards the second half. I will do just a few questions from earlier, but probably not some of the basic simple stuff because they're just so simple. Maybe you guys have had that, but I'll put in a few. I'll grab a few of those questions and I will make up a few questions. I might just make up some calculating questions, just based on what we've been going on. So just to give you guys a little bit of a challenge. I noticed that most of you are the people that got a lot of things wrong. Or I noticed that most of the wrong answers, or people that were unwilling to even answer, were the word questions. A carpenter made $15 an hour for 24 hours, and his buddy made X, and how much did they make? Stuff like that. Just read the questions. You can all read. I know you can. Read the questions and then use a piece of paper and write down the numbers. And then if you need to use your calculator, that's fine. Use your calculator. This is all, use your calculator, use your phone, period. You'll be able to use all that. Remember, you're gonna be doing this at home anyway. You're not even be doing it here. You do it at home. You can use all the resources you can get. You can use the book. You can use the tables on the back of the book. Try not to use the internet. Try not to ask the internet the answers to your fucking questions. All right. I mean, I gotta trust you. This is for you guys. I want you to get a good grade, but I want you to be challenged as well. I want you to take the test. The thing of it is,
is it gonna be like 50 questions or something? Probably?
My typical tests are 50 questions, unless Jim is worn off on me.
Oh, no, don't give us 100 questions.
No, my tests are 50 questions. I don't want to correct more than 50 questions. And I'll give you some bonus questions based on just some stuff. Maybe it's something from the 4 agreements. I've read you a couple of things. There's just some anecdotes from my life, or, where's my wife going? Stuff like that. Just stuff I'm talking about. Just see if you've been paying attention.
Where's your wife going?
The dead center of the country. It's also the seat of American aviation, by the way. Beechcraft, Boeing, all the aircraft manufacturers were at one time in Wichita. Now Spirit is there. That's also a manufacturer, by the way. Boeing still got a presence there. Cessna is still there. That was the home of Cessna. And Beechcraft is there. Yeah, Wichita, interesting place. See, at least golf courses are okay. Not that bad. Okay, where are we? No, customer conversion nominal. Okay, so it talks about lumber sizes, right? Dress sizes. That whole thing about that I was in a little bit of conflict with is when we get over 6 inches, our stuff drops to 3/4 less than the nominal size. So in other words, a 4x12, which I used to think was 3.5 by 11.5, is really going to be 3.5, 11.25. So after 6 inches, it's 3/4 less versus a half less. Like a 2x4 is 3.5, a 2x6 is 5.5, a 2x8 is 7.25, a 2x10 is 9.25, a 2x12 is 11.25, or 1x12, or anything. But the width would be a 1/4, 1.5. And then you've got summary of formulas. You got all these formulas. You got all these kill formulas. All the best formulas are here. The square perimeter formulas, the rectangular perimeter formulas, these are so easy. Triangular area formulas, your cube volume, your rectangular solid volumes, Pythagorean theorem, and your board foot, all back here. So when you're figuring these problems and you're having any kind of trouble at all, go refresh yourself. Go look in the book, man. Look at the formulas and then just apply the formula. The formulas won't lie. The numbers won't lie either. The numbers will, and then a 3 is always going to be 3. It's never going to be 4 or 5 or 2. Okay, numbers should be your friend because they don't lie. The only time numbers aren't your friend is when it's on the scale. I was 172 a month ago. I'm now 178. That is bad. So there's a good glossary here, and an index, and then of course all the odd answers. That's in there too, which allows you to check your work. So go through the way you can study is just bone up and do a few. You don't have to do them all. Just do it. I haven't asked you to do any homework, right? But you wonder why I haven't asked you to do any homework? Did I tell you why?
Because you're a cool teacher.
Yeah, because I don't think you'll do the homework. And I don't want to nag you about it. And I don't have to be a thing. You know what I mean? So just pay attention. Use the book. You guys will do great. You guys will do great on the test. I know you'll do. I know everybody will do great on the test. I just know it. And especially we won't have that that same BS of fill in the blanks. God help me. That was a learning curve for me. I would never, ever do that again. Well, I may do that again. And I was gonna do it again, but then I put together some questions for your final, or for the final of the class I'm teaching with Jim. And I realized, all I have to do is just put in 3 wrong answers and 1 right answer. It makes it easier than having to go back, do it now.
And Canvas grades it for you.
Exactly. Well, that's the whole thing, because so much for Canvas grading it for me when I had to go back for every wrong answer. And basically, 9 times out of 10, the wrong answer was the right answer. I can't very well mark it wrong because the answer is Lin FT and you put LF, or you spelled out lineal feet. It's just but stupid. But really, I didn't bring this up with anybody, but I don't know if any of you noticed, this happened in at least a dozen cases where some of you wrote the exact right answer, exactly how it was in Canvas. You wrote exactly the right answer and it marked it wrong. And I couldn't find out why. I would just look and okay, that's right. That's right. That's right.
Extra spaces will do that to you.
Yeah, Canvas hates your guts, I think. But so yeah, back to something else I want to talk to you about. Back to this test. We will show up, okay? So we'll show up, everybody show up 6 o'clock next Thursday.
On Zoom?
On Zoom, not here. I'm sorry. Don't show up here. Just open your computers, tablets, phones to Zoom. And we'll touch base. I'll take roll. And the test will be open to you. You can start doing the test. And if you can't take the test or be here on Thursday, then you need to take the impetus and call me, text me, email me, and tell me that you want me, and then we can work out how I can get your test to you. And then I won't have to do all that grading and get the test back, and you guys will know right away. And what else? What else is there?
Sorry, probably just lack of doing this so often. In order to get into the Zoom connection with you, the link is going to be sent through an email, or is that just a button while I'm on
Canvas?
Canvas, okay.
It's a
option.
Yeah, it's
Oh,
a,
okay.
it's a, if you will, I don't know if you've seen it, Ben, but I'll show everybody right now. I'll show everybody right now exactly.
Oh. Zoom.
Okay, so see there? Oh, you'll see it in a second. And I'll give myself student view as soon as this comes up. So here's what you all should, what it should look like for you, other than the pink down here, right? You'll have these tabs on the left, home modules, and the third one down to Zoom. And if you just click on Zoom, that will take you to join. So join. Just as simple as that. And leave student view and go back to my view. Stop the sharing. What kind of I showed you, oh, I showed some of you guys were here Tuesday night. Just Lou, really. And maybe a few people at home. I showed them a bunch of stuff. And you guys can see that anytime. You can see construction anytime you want. Does anybody want to stick around and hear me just babble? I didn't think so. Let's
I did have a
yeah,
question.
but ask questions now. This is a really good time to ask questions.
Sorry, it's not about the.
That's okay. Ask about anything.
When you were talking about the code of safe practices at the
Yes,
beginning,
yes.
in my mind, it was like No, that doesn't happen. No, we would fail.
No.
We would just,
You're exactly right, and I had the same thought, so I know I cut you off, but I think what Ben is trying to say or was saying is that, yeah, these safe practices all sound great, right? But are you doing any of those things? Are you doing all of those? No, none of us are. None of our companies are that professional. We're not taking the time to do all that stuff. We're just not. It's a good thing. It's a good thing to study and to have and to keep in the forefront of your mind. You want to do these safe work practices, right? You definitely want to do them. By the same token, you're not gonna, I mean, we could go back through that, but some of those things have kind of said, right. we can do that. Luke,
In relation to that company that you said they have to insure people,
yes,
are their rates more than other companies? Or
since it's been deregulated, generally their rates are up there. It's all over the map, to tell you the truth. You can't count on them being high, but you can count on that you can find less rates, better rates.
If those other companies will insure you.
If you can get them to insure you. If they're doing, insurance game is a really crazy game.
Yeah.
And workers' compensation is just, I just think it's a scam of the century. And, basically, most compensation claims are fraudulent. They're bogus. Guys just, they don't want to work. And now that's not to say that there are plenty of legitimate claims. And workers' compensation is great, but here's my thing about workers' compensation. I don't know if I've told you guys about this. I don't know if I've mentioned this, but my opinion of insurance is it's legal extortion. It's basically the mafia in a white suit. It's unbelievable. It's legal extortion. It's like you pay, right? You pay us, so nothing bad happens to you. And then when it's bad, then, oh yeah, then we'll take care of you. So, but my thing about workers' comp is that I'm your employer. I provide you a safe, clean environment. I pay you well. I help you buy tools. I provide tools. I provide safe working conditions for you. By your own negligence, stupidity, thoughtfulness, disregard, you're too loaded, whatever the reason, you hurt yourself. Nothing I did caused you to be hurt. Nothing. I did everything so that you'd have a safe environment to work in, so you wouldn't get hurt. But you do something stupid and hurt yourself. Now, do you pay? No, I pay.
What if it's someone else's negligence?
I still pay.
Yeah, but then it wouldn't be your fault.
It's never my fault.
Well, no, but it was like, if I get hurt because he's doing something stupid, it's his fault.
No, I know, it's just, it doesn't discriminate or differentiate between that. It's like you get hurt, then we pay. I pay. The insurance pays. It's great that you got comp and we'll take care of your medical and then the disability, we take care of if you can't work and stuff like that. That's all great. And I'm all for that. But, the onus comes back on employer. We provide all this stuff and then you do something stupid and then we have to pay through the nose. Like this whole thing with where my mod rate went to 2.25, which virtually put me out of business. I paid 225% more than anybody should pay for their workers' comp doing what I did because of my experience modification, because of this giant claim with this guy that got smacked in the head with a telephone cable and he wasn't even on my clock at the time. And somehow, it got picked up as a claim. My company honored it. Oh, and what I wanted to say was workers' compensation, they just roll over. They don't go after people, even if they know they're faking it. They just don't. They don't want to spend the money. It's easier for them to just pay it out. If the lawyers they're all in collusion. It's like, yeah, come on, give me this guy and I'll give you that guy. Give us the 50 and lawyers get 40% of that, 25, 33, 40%. So you hire a lawyer to work on your comp claim or work on your personal injury or whatever it is you're suing whoever for. They get 25% of your award if it happens with a few phone calls. If it happens with more than a few phone calls and some letters back and forth, they get a third. And if it goes to any kind of court or litigation, they get 40%. They get 40%. They get 40%. And, that galls me in some respects, but in others, because I have well, my best friend was a lawyer. He's deceased. But he worked for the little guy, and he worked for his money. You know, he did industrial accidents that resulted in death or dismemberment or you know, amputation, stuff like that, national all over, and he fought to get people money where the big companies were trying to say it. And some of his cases were just, oh my God, just so interesting. Like, do you know those machines that chew up the asphalt? Yeah, they chew up, they're big roller, right? These big carbide spikes, and they just chew up the asphalt, and then the asphalt goes shooting up into the back of a truck, right? And they grind that up and use it for roast base. And it scarifies the road so they can put new petromat and then new asphalt and topping on. Well, that machine is stopped and idling with the clutch in, and the supervisor and a guy are in there changing one of the carbide teeth, and somehow clutch engages and it grinds these guys up.
They did that with the
Grinds them up. What's that?
They did that with the machine running.
Yeah, I guess it's too hard to shut down or something. I don't know. Just this unbelievable stuff. A guy I filmed, one of his cases was at the Napa Pipe Company, which used to be a Kaiser Steel company. They make pipes. They make these unbelievable. They make 40-foot sections. This one run that this guy got injured on, where pipes roll back and just smashed his hand flatter than a piece of paper. So heavy. 40-foot long, 3/4 thick steel, 3-foot diameter, whole steel pipe, 40-foot long.
How did his hand get stuck?
Pardon me?
How did his hand get stuck?
He was inspector, right? So when they roll off the line, he gets in there with a light and looks at them, right? And he's got his hand on the pipe. He's shining his light in, and this one pipe rolls and just rolls under his hand. Didn't get much, just, you know, rolled about that far, but with that heavy, it just flattened his hand, broke every bone. I mean, I'm not sure. I don't think he was amputated. That was pretty bad. But I thought it was really interesting because the guy, I talked to one of the workers there, and he said that, you know, when it was Kaiser, they make the steel up in Oregon, they ship it down, these big flat, you know, 3/4 plates on railway cars, and they get there and they cold roll them. Cold. Yeah, it's rolled cold underwater and under pressure. This incredibly, these giant tanks, and it does stuff like when it's formed into a circle, it actually shrinks like a 1/2 inch. The molecules, just like, it was really interesting. But they bevel the ends, and when they roll this, the ends come together, right? But they're beveled, so they have a V, an empty V, and that's where the weld goes. And these are all gas pipeline. This is the stuff up in the Alaska pipeline to carry the gas. But I loved stuff like that. I just loved. I loved my friend's cases. They're all so interesting, and you know, and big numbers. I mean, you know, lots of big numbers. But these guys, you know, they would go for years, and they front the whole thing too. You know, they would, you know, their people, their clients would be down and out. They'd give them money, you know, advance them against their, you know, they felt good enough that they were going to win the case or get some kind of a judgment. Advance them money, but you know, they pay their people and all their experts and the research are flying all over the country to depose people. They paid me to film. That's really something. Yeah. So I talk bad about lawyers, but really, I think there's some really good attorneys and good things that attorneys do. But again, attorneys are on my shit list. Like insurance people want to do the same thing. I'm pretty close.
Rodney.
So here's something I want you to think about. All right. And I want you all to think about this, and I want you to tell me the next time we see each other, which is going to be 1 week from today, not here, but we're going to be seeing each other on Zoom. I may be here, but I may very well be at home. With my wife gone, I'll probably be here because I don't have anything to do anyway. So I want you to think of 3 things for yourself. This is very personal. 3 things that 3 talents that if you could have them by wishing them, you'd have them. Now, let me give you an example. I'll tell you my 3. All right. If I could, I would be a scratch golfer. I'd shoot scratch and be a par golfer. That means if the course par 72, that's what I'd shoot or under. I'd be an operatic quality singer, sing anything, right? Any key, and I'd be a virtuoso on the piano. Those are the three. Piano. I could play anything on the piano. Concert quality pianist, singer, golfer. Those are the three talents that if I had my druthers, I would. I want you to think about what would the three things you would be, and I want you to tell me next week.
Like professionally, or like
No, just
really good?
just for yourself. I mean, well, yeah, professional quality and above. Yeah, like virtuoso quality. Like what I'm saying is that if I want the talent to play the piano where I could play anything. Name a song, I can play it, right? I can play Tchaikovsky's. Maybe we can't think of that tune by Tchaikovsky.
What was that?
Backflips,
Oh, backflips.
that's mine.
Oh, what now?
Doing backflips.
You want to be able to do a standing backflip?
Yeah.
Dude, get down. So really take it to where that needs to be. D'Angelo, take that to where that, what you really mean is you want to be able to be a gymnast that can do anything, right?
Oh, yeah.
That means you could do iron cross, you can do a triple, you can do giants on the bars, you can do standing backflips, right? Yeah. Or you want to be a circus tumbler.
Do it at parties.
Hardcore.
12 to 21, ask class for 3 talents. And then you'll be graded on your talents. Just- oh, that's a shitty talent. F. Oh, I want to be really good at sewing. F. I want to be really good at dyeing my hair. F. Okay, no, just kidding. Those talents are perfectly good, man. And I encourage you. And if those are your secret talents, and I have just rained on your parade, oh my God, I'm so sorry. I apologize in advance. What is wrong with this camera? What's that? Yeah, it's not happening. Huh, weird. It's just totally.
Fuzzy, right?
It's what?
Fuzzy.
Fuzzy as hell.
Yes, I've noticed it happens with the change of light.
We're still.
You're staring at a fuzzy screen.
Wow, it's really fuzzy. We're still recording. Oh. Huh, wow. Well, you guys can see it's me, right? Sort of. Okay, so any questions about this, about calculating measurement? Think of any, and just interrupt. But I wanted to tell you that I had hoped with this class to be able to project like the Mangone's plan, and we do some takeoffs from the plan. Just didn't work out that way. And I'm pretty happy with the way it worked out because I really like this book. I like the way the book took us through the basics and then got us into the things that we can apply to construction. All of it's applicable to construction because math is huge in construction. And this gives you a pretty good basis. So if you've mastered these math techniques, you should be good in construction. You should be able to use math in construction and use it to your benefit. And the more you use it, I suspect the better you'll be at it. Right? You can get those things in your head. You can get those times tables in your head where you can start doing stuff in your head. Like that whole 15 times 15, I just knew that's 225. I didn't do that in my head. I've done 15 times 15 enough for some reason, like 5 times 15 seems to, and I know that's 75. So I've done enough numbers and enough math in my head that I really know the numbers come and I know they're right. So I feel confident with that. And, you know, it's pretty important. If I think about it, and I do a lot, I think, and the reason why I think about it a lot lately is because of the shade structure that we're building in CT110. It's a relatively simple structure. You know, it's a slab. It's with 4 column bases. It's got 4 posts. It's got 2 headers and 9 rafters and 9 or 7. I can't remember how many sheets of corrugated metal roofing, and yet it's not easy. It's not easy. You know, there's just a lot of figuring and a lot of measuring and a lot of figuring stuff out. And then I look at really complex projects. Like, have you seen that project? Did I mention that project? That was a $160 million project? Did I mention that?
Was it the one on the beach?
It's on Woodley. It's $160 million construction cost. And my friend Jerry DeHogue, who's a Finnish carpenter, has a company called Trimworks. He'll come and he'll hang a door for us. He'll do a demo. He'll do a lab for us in CT114 or maybe 115. I might have him do both of them, but he'll come and do a lab for us and hang a door. Or I'll do it, or I'll just show his video, depending on how lazy I am. I probably want to get him to come because you should see this guy and you should see how he's tooled. He's unbelievable. So he's probably as high end as they get. There's he and two other companies. eWorks is one guy. He's really good, and so is my other friend, guy that worked for me, Byron. Solid Rock Construction. I can't think of his last name right now, but these guys are really good. But Jerry is doing the finish work on this $160 million. That's the construction cost. Can you believe that? It's a 300-foot. I don't think it's diameter. So what would the diameter be of a 300-foot circumference? But it's a dome. It's a concrete dome. This house. You want to see it?
Yeah.
Concrete dome.
Yeah, I couldn't find too much. God, this is horrible. I couldn't find too much on it, but I did find a couple of things. But I've got to pose as one of Jerry's employees. I got to get hard hat and one of his T-shirts, and I'm going to go in there. I'm going to take some pictures.
What part of town is it in, Rodney?
Do you know where? Okay, so this is good. You guys will appreciate this. So Brooks Institute, right, which is up off of Woodley. It's actually up Alston Road. It's Brooks Montecito campus. Brooks is no more,
Right.
but their Montecito campus was this unbelievable estate, all concrete, all masonry, poured concrete ceilings. This giant estate that I'd done some work on. I created, converted 2 classrooms and demoed the bathroom in between, made them into one, and just learned all these incredible things about the building, right? And it's on a couple of acres, 2 or 3 acres, and it's got outbuildings, and it's just an unbelievable place. Well, they were complaining because the house next door is the house we're about to look at, the $160 million construction cost house. They were complaining about something, construction noise, and you know how they dealt with it? They just bought it. They just said, "Oh, how much do you want for the place? 20 million? Oh, we'll take it." So, any more complaints?
Wow.
Yeah. Wow. I just couldn't believe it. What? Really? Yeah. Really? Oops. I want to do that. I want to just hide the photo video controls. Okay, so let's go to I think it's 351 Woodley Road. Yeah, can you imagine? Can you imagine? Wheatley Road? What am I thinking of? 420 again?
Is it that time?
Okay. The craziest, coolest house is under construction in Montecito.
Do you know what the owner does for a living?
Yeah, I do, as a matter of fact. It's Linda Weinman and Bruce Heaven, and they own a company called lynd.com. Yeah, Linda, right. Lynda.com. I think they are financiers, but there's some of the steel. I think it's a lot further along than this now. Yeah, so I bet it's 300 feet in diameter.
Wow.
And this is, like I said, it's further along than this now, but is that insane?
That's concrete, right?
That's concrete. That's CIP or PIP. So do you know what CIP is? It's the same as PIP. Do you know what PIP is?
CIP.
Yeah. CIP is cast in place. PIP is poured in place. Same thing. So it's concrete that's formed and then poured in place. So walls poured in place, ceilings, roofs. I mean, look at this. It's just so apparently. So
Yeah, I know the house.
now I'm going to show you this.
I worked right next to it.
Do you?
Or yeah, we had a job right next to the house.
On Woodley?
Yeah,
Cool, man.
the house is amazing.
Um,
It's come a long way.
Yeah, from there. Yeah, I hear it has. And I'm gonna, well, if he's in there hanging doors and doing trim, But apparently he told me these forms, like all these forms, imagine the forms that created the curves were all made by some giant cabinet making company somewhere back east. And they came on trucks with cranes. But so a cabinet making company made all the curved forms. So like millions in just the forms. Now, what do you do after you pour the concrete, the forms like that? What are you gonna do with the forms? You're not gonna reuse them. They're out of there, man. I wonder how they even recycle them. But here's some pretty interesting, these are renderings, right? So this is not it, but this is what it's gonna look like. Looks like it's gonna have a little moat, and it's gonna have a live roof. The roof is completely live. Does it? And so you've seen the structure, no?
Yeah, they're putting plants in. Already.
And if you look, I don't know when this was taken. But I was looking for it, right? I didn't know the address. I didn't know where it was. I had no idea where it was. Although I remember Jerry said something about Brooks. So I just went to satellite view before I knew the address, and I saw this. I thought, oh, I wonder if that's it. Is that crazy? That's a house. That's somebody, and then guess what? That's a single family dwelling for a couple. I don't even think they have kids.
How many rooms is it? Well, they got, I see they got a pool there.
They do?
And a pump, well, yeah, in that little middle area.
Yeah, right here, you think? Or you
No,
think
the other side of it,
over here?
right there, that looks kind of like a pool to me.
It does, or maybe a moat. Who knows?
Lazy pool.
But check this out. This is the property line. Right, actually, that's probably them. No, this is Brooks. I think that's their property. And this is all Brooks, right here. This is Brooks. That's what they bought for, I don't know how much, but you know, it was multiple millions. There's the turnaround. This whole thing is Brooks. This whole hilltop is all Brooks Institute. And they own one of these houses too. Ernie Brooks. There's that rotunda. I staged here with Penhall and busted out, I don't know how many tons of concrete to do this classroom thing. That was quite the job. But how about that place, huh? So with some luck, when I see y'all again next semester, I'll have gone inside and taken some surreptitious pictures of my
You're just sneaking at night.
at night.
They just top some fences.
They're open during the day. It's not like they're open.
It's probably a better idea, Matthias. While you're in the day. Less chance of getting shot or arrested. I wonder, are those all roof penetrations? I'm just so curious to see what this thing looks like. $160 million to build a house. Wow. My parents bought their first house. It was a brand new house in Kansas City, Missouri, in 1953 for $17,500. Wow. It was a 4-bedroom, split level and a half acre. Wow. $17,500. Something else, huh? But imagine, just imagine, look at that.
Look at that burger.
That's crazy. And that's how much it'll blend into the land. I mean, pretty wild. Oh God, this blows me away.
When we first saw, we thought they were building an underground bunker.
Yeah, I bet. I
Who
mean, you can't
knows?
just.
They could be going even deeper.
It could be. It sure as hell could be.
Have you seen how big that thing is?
So according to the family, there'll be a new 10,720 square foot single family residence. Holy crow. With a 5,387 square foot basement. You're right. What are they gonna be doing in that basement? 1,945 square foot attached garage, 2,000 square foot, same size as my house, their garage. 707 square foot workshop, 710 square foot pottery room. So that including the basement, the total square footage is almost 20,000 square feet.
Who needs that much room?
Yeah. Somebody obviously wants that much room. I don't know, if you had that kind of money, if you had billions of dollars, you'd have to figure out some stuff to spend it on. Otherwise, what good does it do you? What fun is just sitting around, kept watching your money grow?
Bloating in people's faces.
Hmm?
Bloating in people's faces. Look what I have that you don't.
Yeah, and you all know, right, that that wealth,
There's a bar.
monetary wealth doesn't equate with happiness.
Yeah.
Right? And do you know that happiness is not a feeling? Happiness is a result of some feelings, some pretty macro feelings. Satisfaction is one of the components of happiness. Fun is another component of happiness. So what makes you happy?
Is that another question for the test?
Having money to buy the things that make you happy, to go golfing.
Look, you know what? I've had no money and I've had money. And I like having money better.
Yeah, I'm willing to take a chance. Money
But
doesn't buy you happiness.
that having been said, the root of happiness is to happen. That's the root of happiness, is to happen. So really, in my way of thinking, true happiness is about what happens. And it's like the Dalai Lama said, the secret of life is not getting what you want, but wanting what you get.
Once you have it,
I
you
met
didn't
the
really
Dalai
want it.
Lama.
Pardon me?
I met him.
You did? I did too. I was about to say that.
He went to our
Where'd you meet him at?
Our school.
At your school? You came and talked to your school? Yeah, I got to meet him at something at the Red Lion, yeah. Red Lion.
He did the sand sculpture thing.
Yeah, cool, man. He's a pretty powerful presence, the Dalai Lama, by George. It's a real shame what's happened to his country too. Just when you think China's okay, they're not okay. Just between me and you, at all. And they seem to have so much dough. How did I get here? Am I still sharing the screen? They seem to have so much dough. Right? Seems to be so much wealth in China. There's so many people in China, so I'm sure there's just a whole lot of wealthy people. But I had two Chinese students, male students, rent my house for 6 months when I first sold my business in 2015. A couple of really nice kids. I really liked them. I didn't meet them but a couple of times, but they seemed really nice. They drove up in a convertible, brand new Jaguar coupe.
Wow.
Brand new black convertible coupe. Right? And I wanted X amount, and I wanted $6,000, deposit. They just had no problem with anything. And then of the deposit, after 6 months when we came home from our trip, they said, "Oh, just keep it. You're already going back to China." They bought our house was furnished, but they bought all new bedding, right? So they had all comforters and sheets, stuff like that. They bought rice cookers and all that. They left everything there.
Wow.
Everything. Rice cookers, all the bedding, all that, everything they bought, they left. So
What about the car?
I had to charge them for throwing. Yeah, and they didn't leave the car. I asked about that. Dang, what were they thinking of? I think it was on a lease. But okay, so what is it? God's 8:30. I just talked your ear off. So I won't see you again until next year unless I have the good fortune of seeing you in some other place. But I will see you on Zoom next week at 6 o'clock on Thursday, correct?
Correct.
We good? Good night. Have a great time, you guys. Stay warm.
Thank you.
Stay warm at home.
Yeah.
Thank you.
Jose and Zach and Jacob and Miguel. Miguel, you made it.
Made it.
Miguel Barbosa made it.
Yes, sir.
Right, mark you here, Miguel.
Rodney,
Thank
can you hear us?
Here, Miguel, what happened to you last week? Did you show up late or something?
No, last
Are you
week I
there?
had funeral services.
Oh, wait, let me turn this up. I can't hear you. I'm sorry, Miguel, what was that?
I had my brother's funeral last week.
Oh, I'm so sorry to hear that.
Thank
Dang,
you.
really sorry. I'm gonna give you an excuse then. That's a good one. And Matthew Aguinaga, you're not there, but how's it going, Miguel? You doing all right?
Good. Yeah, I'm doing good. Doing good.
Good deal. So any of you that didn't hear, next week, show up on Zoom. And you can ask me questions. The test will be available at 6, starting at 6 o'clock next Thursday. We can talk a little bit about the test and then we'll say bye-bye. You guys do the test. Canvas will publish the grades, okay?
Okay.
So
Rodney,
yes.
on the first day of class, you said that if we stuck around to the end, you would tell us why the secret to life was times tables. And that's half the reason I stuck around.
It's not the last class yet.
Oh, so you're going to tell us on finals day.
Yeah. You gotta
Okay.
remember to ask me though, all right?
Okay, I'll set a reminder.
Okay, good.
Are you gonna record it? Because I'm not gonna be here for that class.
Yeah, I'll record it.
Okay.
Sure, I'll record it.
I wanna hear that.
Yeah, I'll record it. I'm gonna stop.